Hi everybody, this video explains how to use the Bedloadweb program. On the welcome page you have explanation about the Bedloadweb project as well as the objectives of the program. You can access to a French version or an English version of the program. Here is the English version. In the menu you have 4 tabs. The second tab gives access to a large dataset. This dataset concerns Flume and laboratories. We'll come back. Laboratory and field data. We'll come back to it. The toolbox gives you access to several tools for computing a sediment budget project. And in the Help tab, you can upload a user manual in PDF format explaining all the functions available in the program. You can also upload an manual explaining the equations as well as an example file for the toolbox. Let's come back to the database. In this page you can see 2 sub-tabs here, select area or multi-criteria selection. The first sub-tab gives you access to individual datasets considered separately, so you can, for instance, select a river. Here we'll select Big Wood. In the list, what you can see on the figure is an update of the selected dataset with the red crosses are the data and the lines correspond to different equations. You select here in the right panel. Let's, for instance, change the selection of the equations. Okay, and you can just keep some equations for the test. You can download the data in a text format. Below the figure you have several options for displaying the data. You can plot with different parameters. Okay, shear stress, flow power. On the right panel you can test the sensitivity of the models to different parameters. For instance, you can change the slope and see what happens. Okay. You can change the D50 and see what happens. Below this page, you have access to a description of the bedload current size distribution for the given selected river. If you change the discharge, you see how the grain size distribution evolves with 3 methods of calculation. In green is the bed grain size and the other curves correspond to the bed load grain size. At the end of the page you have a reference to be used if you use this data in one of your papers. That's it for the first sub-tab. As you understood, it's purely educational because you can test the sensitivity of the different models for different flow and sediment conditions. We can reset these different values. Here you also have some option for the calculation. You can, for instance, correct the shear stress for bed form resistance. Now we can look at the second tab, which is a multi-criteria selection. This time you will not select only one river, but you can make a selection inside the whole dataset. For instance, you can just select a few rivers by clicking in this large set of rivers, and by clicking on the orange button you will have access to the graphical representation of this selection. Let's come back. We can reset this selection. Here you can choose to display only a data in slope between 0.01, for instance. Oh, sorry. And 0, 2. And for instance, you can restrict to D50 between 25 and 30. So here you can see that in the database we have 4 datasets corresponding to these criteria with 2 flume data and 2 field data. We can reset. Now if I go to the graphical representation, I display here the whole dataset, more than 10,000 values. What is interesting here, maybe you can just compare different, let's plot here, you can change some graphical options. You can compare, for instance, the flume data with sunbed data, or with step pools, or with riffle pools. So you see we can change different aspects of the representation depending on the morphology of the river. You can do the same for the measurement techniques. For instance, you can compare the basket sampler with the flume data or with the sediment traps, etc. Here you have the possibility to change the graphical options, so you can display your data with discharge, with the flow depth, with the shear stress, with the shield stress, with a shear stress ratio. You can compute this ratio with D50 or D84 and see what happened. Okay. You also have different options for the graphics. You can change some values here. A summary is given in this table. Below this page, you have possibility to test the equation on the selection. So you can choose different equations and do your calculation with different options also for the calculation. Start the calculation and you will have a graphical representation of the results of your calculation, as well as in the table different scores displayed in this table with different envelopes. This last tool can be interesting, for instance, if you want to compare your equation with some river characteristics which are of interest for your study, for instance. So it's a way to validate equations too, if you want to select in a given slope range or grain size distribution range. That's it for the database. Now we can have a look to the toolbox. In this toolbox you have different tabs. All these tabs correspond to a given step in a sediment budget study. First of all, you will need to save your entry. If you spend several hours entering data, you will need to keep this data to save to produce a backup. So you can do a local backup, which means that you will save all your entries in a text file on your computer. For this option, you don't need to create any account. You just click the button and all the data will be saved in a text file you can use later. If I have a look, you click on this button, download the project, and if you want to use again this project, you will have to import your file here with this button. We will not use this option today. I will show you the other option, which consists to save the data on the server. One interest of this option is that it permits to save not only the data, the numerical values, but also the photos if you insert photos in the website, as well as the project description, which is a full free text you can write to describe your project. To create an account, you just need to enter a login, password, the email is not mandatory, but you must know that if you lose your password and you ask the webmaster to give you access to your data, only the email will allows to recognize you as the owner of this data. So if you do not enter an email, keep in mind that if you lose your password, it will not be possible again to get your data. The file sharing code is not mandatory too, but it's very useful if you want to share your data with other users. All that is explained in the user manual. Now let's try this option. Okay, I logged with my name and I have access in this menu to different features. So for instance, I can see all the projects which has been already saved in my account. I will create a new project. And I create this project. The name of the project appears here. The page indicates that for the moment I've created no grain size distribution, no section, and no hydrographs. I will start by creating a grain size distribution. You have access to this menu with here different possibilities to save and create new grain size distribution. Two options are possible. Either you use data you collected in the field or you use a model. Let's try to create a new grain size distribution with data, for instance, a Wallman count. So you enter your values. Okay, here is the grain size distribution and you save it. We created a grain size distribution, so which name is GSD1, and this grain size distribution is composed of one sample which is ECH1. You must understand that one grain size distribution can comprise several samples, which means that if, for instance, you can do several Wallman count in a gravel bar and compose this sample to create your grain size distribution. Give a name to this grain size distribution. It will be easier to recognize it. Here is the values of your grain size distribution, and okay, we can add a new sample, for instance. Now use a model. You will need to enter at least the D50. Here is your new grain size distribution and you save. This time the new grain size distribution is average the two samples. You can just select your samples. In green is the sample and you display here the selected sample. The resulting grain size distribution is in this table. And you must save your grain size distribution. Keep in mind that what you save here will take into account what you has already saved here. If, for instance, you create a sample but you don't save it, when you save here, you will not take into account the sample. This is why you have several messages at the bottom of the screen. If I save, you can see two messages. So you need to save a sample before saving your grain size distribution. And the other message tell you that be careful because for the moment you have saved only your grain size distribution. If you close the website now, you will lose your data. You must for definitive backup, you must save your project. Okay, and now your projects comprise one grain size distribution. Now I can create what can be interesting also is to add an image for your grain size distribution. where can I find that? For instance, I can add this image for describing the site where I did my measurement. And once again, I save. Let's create a new grain size distribution with, again, I can enter values of my Wallman. Okay, it's not realistic, but never mind. Okay, save. I've created one grain size distribution, and I can add a new sample with a model, for instance. Okay, this is my new grain size distribution. This time, if I go back to my project, I have two grain size distributions. Okay, and I can open again my first grain size distribution by selecting it in the list. Now we need to define a cross section. For the cross section, you have two options. The first option consists to use a model. For that, you can select different trapezes. You will play with it and understand what it means. You can superpose different trapezes. And you create this way a channel with different parts, and you can add a secondary channel, for instance, with this option. These slides permit to very quickly change the size and the position of the different part of the bed. Now we need to go back to the cross-section entry with this orange button, and what you have created is now in this table. You can change a value if you want to modify the section. You need to enter a slope, it's mandatory, and give a name to your section, it's better. Okay, save. Now you need to define in this section what is the main channel. The main channel is where the main flood occurs, and the active channel, which is the place where bed load is active. You will have many explanations of these aspects in the help menus here with different morphologies, and it explains for different morphology what are these bed components. It's better to define the morphology of this river. It can be useful for some bed load formula. And once again, you have an explanation of these morphologies here with the help button. Add an image to this section, okay, so that you can have a good illustration. And you save. We have one section. Now the project comprises one section and two grain size distribution. Go back to the section. We will create a new section. This time we can import a file. Okay, this one. This is a text file with two columns, X and Z. The name of the section, and you save. You need also a slope. Okay, you save it. Once again, you need to define the main channel. The active bed, a secondary channel, maybe, not necessary, it depends on your river. You can also define some special areas like this one, which is a roughness area, which is a part of the bed, for instance, where you will have a special roughness, for instance, with vegetation or something different to standard gravel beds. Okay, and you save. This time our project comprises 2 sections and 2 grain size distribution. Once again, save your project, otherwise all is lost. Now go to the hydraulics part. What will be displayed is the section which is open in the cross-section page. Here, section 2. Okay. If you change the slide with water depth or discharge, you will display the hydraulics values corresponding to this discharge. What you can do in this page is to change the roughness of your bed. For instance, you have 2 options for computing the hydraulics, the Ferguson equation or the Manning-Strickler equation. The Ferguson equation uses the bed grain size distribution as a roughness. The Manning-Strickler equation requires to enter a roughness coefficient K. Here you have possibility to change the grain size distribution to be affected to the different part of the channel. So usually we recommend Ferguson equation for all parts of the channel covered by gravels and keep the Manning-Strickler equation for the other part of the bed, like for instance where the bed is covered by vegetation. Say, below you will have access to different rating curves. You can also upload some validation data if you have, for instance, if you measured velocities, depths in the river, and you can compare it with your the fit of the model. Now you have defined your hydraulics, you can go to the sediment transport page. This time the program displays the result of the sediment transport for the considered section. 4 panels are displayed. You can have a zoom in these panels by clicking on this button. For instance, you can show the models. QS is the discharge for a given flow depth. Okay, you can change the value of the discharge and you see what are the results in terms of sediment transport. And the granulometry is also the bed dot grain size distribution corresponding to this flow, to this discharge. A summary of the hydraulic parameters are given here. You can, for the models, upload validation data to check if your data fit your models. If you have such data, for instance, if you measure this data in the field. Here it's not so good. You can see that the model does not fit the data very well. Okay, if you go to model, you can also you can play with this menu, but for instance, for the equation, you can change the parameters for each equation. For instance, the critical discharge or shear stress for each equation. You can adapt to fit your model. And you can see that by yourself. You have different possibilities to test this program. The granulometry, if we zoom in, we will have here again possibility to upload validation data for the grain size, Bedload grain size distribution. And you can change many parameters to fit your data, to fit your model. Okay, we save. Now we can adjust this for the different sections, but usually you don't really have to change any parameters in this sediment transport because it uses what has been already entered in the other pages. To compute a sediment budget, you will need to define an hydrology. Once again, you have several options. You can either enter an hydrographs, which is representation of discharge as a function of the time, or you can enter a flow duration curve, which is a statistical representation of your hydrology. Today we will use a hydrograph. You have 2 options. You can build very quickly a short hydrograph by fitted on the shape of the section which is open. Now the section is the one which is open in the cross-section table. So the program uses this geometry to create a short triangular hydrograph. And you have this result here with different values you can change by hand here. Once again, give a name. Very important, you must define the units of your hydrograph here. Okay. And now we can create a new hydrograph by this time importing a file. You can see this hydrograph imported from a text file, which is 2 colon T, time and Q. Don't use bracket, don't use special characters in your text file, otherwise it can make problem. Okay, natural, and save it. Now we have defined, if we go back, once again you can go back to your triangular hydrograph or your natural hydrograph. And if you go to your project, once again, think about saving to keep your data. This time we have defined 2 sections, 2 grain size distribution, 2 hydrograph. Now, to finish, we will compute a sediment budget. You go to the last page, and once again, the calculations correspond to the section which is open in the section tab. To compute a sediment budget, you will need to associate a hydrograph with your section. For that, you go to select in the different tabs, in the list, the hydrograph between the list of hydrograph you have previously defined, and you save. And you open, sorry, you open it. You open your hydrograph, and as you can see, you display the hydrograph with the result of calculation for each Bedload transport model. You can remove some models, you don't have to compute for all models if you can choose some of them, for instance. One important aspect is that you need to adapt the hydrograph to the size of the calculation section, because usually the hydrograph has been measured in a gauging station, which watershed area is not the one used for the Bedload computation section. So if, for instance, the watershed is 250 kilometers, maybe your actual area for your calculation will be half this value, and you need to define this value to adapt your hydrographs. This option, allow calculation, is that maybe sometimes your discharge will be so high that they cannot pass through the section you have defined. So this option allows the program to continue the calculation by tracing vertical walls in both parts of your section if you are, in this case, of very high hydrographs. You must define here if you want to represent real volume or the volume of sediments with a pore, means with the air between grains. You need to define the different units too. You can display either the hydrographs or the total volume transported for the event for the hydrograph. Okay, we have almost finished. Now we can save. I can do a sediment budget for my section, my other section. For instance, if I go here, I must select thing about saving. Let's open the first section, okay? And I want to create a sediment budget. I do exactly the same. I will choose my hydrograph and compute the sediment budget for the section 1. Okay, and I save. If I go now to the analysis page, this page only permits to compare the sediment budget you have done for your different sections. And for different equation, you choose the equation you want to test for this comparison. Here, you compare section 2 and section 1 for this equation, and you can see here a statistical representation of your calculation with a median value and extreme and quartiles. This can be interesting, for instance, if you want to compare sections in a watershed from the upstream part to the downstream part to compare the sediment budget, how we propagate from upstream to downstream. Okay, now it's finished. I hope you will enjoy this program, and I invite you to read the user manual for more information. Goodbye. Okay.